So welcome to Predictive Analytics and Long-Term Planning Processes. This is the panel for that conversation. Hopefully you're all in the right room. If you're not, you should stay anyway. It's going to be a great conversation. So I'm joined by I'm the moderator, Brent Sitterly, Chief Executive Officer and founder of Fixed Point Analytics, data science as a service company. And then I'm going to go down the road here and let everybody introduce themselves. We'll start with you, Ali, on the end.
That was the last one. Thank you for having us here. Good afternoon, everyone. Ali Mohammed. I'm the Senior Director of Innovation at the New York Power Authority. I oversee the R&D department, the Agile Lab, which is the Advanced Grid Innovation Lab for Energy, as well as any other technological, new emerging technologies that come out. We do pilot that as well and support our customers as well as our business units internally. And I'll pass it over to you, and then we'll have a conversation.
Sure. Good afternoon, everyone. And don't y'all have better things to do at 2 o'clock in the afternoon? I'm like, wow, the room is packed. All right, Peter Muhoro, Rappahannock Electric Cooperative, Chief Strategy Technology Innovation Officer, and got a portfolio of different things: clean energy, IT, fiber, broadband, corporate strategy. Things that can't be figured out just get thrown at me, so I feel like that's my everyday. I'm also the Executive Vice President and General Manager of an IT company we created called Brilliant, with a lot of focus on data analytics. And the vision there was thinking about, when you think about the median electric cooperative has about 20,000 meters with less than 30 or 40 employees. They'll never be able to have the expertise that they need for data analytics and the future of it. So we created a company that can actually be a provider of those services, not only to us as a co-op, but also other co-ops. So,
good afternoon, everyone. I'm Sadia Ravindran, VP of Industry Solutions at Uplight. My team and so I run the pre-sales, technical sales team. So we work very closely with our utility customers, our partners, to be able to operationalize DERMS and virtual power plant solutions and help drive the energy transition forward.
All right. So I think what I want to do to start off is just get like a bit of a baseline about how you guys have been seeing predictive analytics supporting the long-term planning process. So if we could just go down the line again, we'll start with you, Sadia. What is one pivotal role you see with predictive analytics in supporting long-term processing?
Yeah. So I see the role of predictive analytics on both sides of the equation, right? So one is identifying the size of the problem in terms of how much to plan for, what kind of demand growth are we planning for, where are the constraints within the network likely to occur, and what is that likely to play out in, as we consider different scenarios in terms of degrees of electrification and degrees of, with the additional load coming in from data centers and so on and so forth. And then on the solutioning side of things, it's also being able to deploy these new technologies that can take this dynamic nature of the grid into account and to be able to deliver dispatch-grade flexibility to be able to solve some of these challenges that we've encountered in sort of defining the problem space. So it's on both sides of it because you need to be able to use data to be able to assess what you have ahead of you, and you need to be able to use data intelligently to be able to then say, okay, this is how I'm going to solve the problem. So, and I would say if we take the definition of planning and expand it a bit more, it's not just planning on the distribution side, but it could also be planning in terms of your generation portfolio and what that looks like. I'm just slowly rotating here. I don't know what's going on.
it's okay.
I think as the passion in my conversation goes, I'm like, sorry about that. But so I think we need to think about planning just more broadly. And just in the previous panel, they were talking about the role of the end consumer in driving a carbon-free future. And there it is about bringing in this demand-side flexibility to be able to solve these system-level, network-level constraints, right? So how predictable can you get is the real question.
Great. So by show of hands, who here works for utility? Good. So most of you will understand what I'm about to say. You know, there's that terminology, Doug, dumb old utility guys. We've always done it this way, and we just want to keep doing it this way, right? That's really what planning has been like for a really long time in terms of the utility. You know, you look at your construction work plan. What do? You 3-4 years, put it on the shelf, and you reference it periodically and say, okay, we're still on the right track. Usually during budget time is when you look at it, and then you go on another, 9-10 months, and then you look at it again, and you say, well, maybe some things changed, or you think about your, planning for what your power supply needs look like, and usually you're getting in same time as budget. You're saying, well, this is what's going to be the need. That is a very static way of thinking about it in a day and time that the consumption of energy is very variable, as well as the generation of it can be variable as well. So how do I get that close to saying, oh, and by the way, traditionally, what did we do? We just overbuilt systems. So if it's a residential house, I could say based on X amount of square feet, I will need, maybe a 15 kVA transformer and call it a day, because I know they'll never get to even 12 kilowatt peak, So that was the easiest thing to do. Well, that overbuilding just doesn't work anymore. So now I have to ask myself, how do I plan, and where does predictive, and we'll get a little bit into this because I see it more even on the prescriptive side of it, but how do we use data to say, I need to plan for this a little bit differently? How do I use data to now begin to plan and show me where I could get the most bang for what I'm doing? Now, it sounds a little crazy, but the reality of it is, when we as utilities, we know one thing: we work extremely hard, so sometimes we don't work smart. And really using data, and so where we're positioning ourselves and is that every step of what we do from a planning standpoint is involving data. In fact, if you're not asking questions on analytics and what you're doing from a planning, regardless what part of the utility you're at, we've made it a point where at the leadership level, it just wouldn't make it, because we want folks to really be able to ask the questions and take this data. We as utilities have a lot of data. We don't like to share it with anyone. I know a lot of folks are like, yeah, if utilities could just share data. No, we do not like to share it, but we barely use it, right? So we're taking it, using it to plan for it. I'll give you guys just one quick example. We got into aging infrastructure, and that is typically an engineering function. That is, the engineering team goes ahead and they do the aging infrastructure study. They see what is, no, we ran it out of our data analytics group. We involved engineering. Engineering didn't like it because they used to do it the way they've always done it. Well, guess what? After we did it, they're like, wait, so you mean in this zip code, you could actually tell me how many poles are 60 years or older? We're like, yeah. And they're like, oh, that makes my job a whole lot easier. Now their planning becomes a little bit easier because now we're able to give them the tools to really plan a lot more different. And I can get into more examples a little bit later.
So I don't know what utility you work for. We don't work that way. That's why we have an innovation group. So we're really working smart here. But when you talk about predictive analytics and you talk about long-term planning, I think from a utility perspective, you need to start with the short-term planning, right? What are your assets? What are your bread and butter? Start there, and that's the journey that NYPA took in 2017, 2018 with digital transformation. And you talked about creating a tool that employees can take a look and see, what assets are 60 years old. We built a similar tool as well, and the DQI, which is the Data Quality Index, is what you measure to assess the health of the asset. As a utility member, ensuring that reliability and resiliency of the grid is very critical, and ensuring the uptime of your assets. The DQI for some of our major assets was 69%. Which is very low for a utility. And when we looked at the results, we formed a group and we assigned different positions in with data stewards, data custodians, understanding the different roles people play when they use data, when they input data, and ensuring that there's consistency throughout the process. And when we did that, over a period of 2 years, for those same assets, we went from 69% to 99%. So now you're talking about applying AI we know the quality of the data that we're using are good. So, like I said, starting short-term goals, that's how we do it. NIPA does not have distribution, so we don't worry about the feeders at the distribution level. But from our perspective, being a state authority as well, we also have to understand the challenges of decarbonization, and that's where the long-term planning comes in, where we have to assess our assets first, ensuring that our assets can support. And like you said, we overbuild. We tend to overbuild. Transmission in New York probably is being utilized at 50-60% capacity, but we have almost $11 billion worth of projects to add additional transmission just because you're going to build renewables down the line. So it's understanding what your assets are capable for, having a conversation with your independent system operators to understand what they're comfortable with, and that's where the planning process starts. And then you can apply predictive analytics to it because now you have the right data to apply to.
So these are all great points, and you covered my sort of subtopic. Everyone did, touched on it briefly, but I think I want to push a little bit deeper. We'll stay with you, Ali, on the DQI numbers that you gave. What are, within utilities, what do you see them actively doing or actively avoiding doing that's putting this a pivotal role of predictive analytics at risk? So you talked a little bit about data quality. It would be like a place
So
to...
just to expand on that, when you look at data quality, there are 7 attributes you're looking at, right? Accuracy, consistency, timeliness. I can't remember all 7, but those were some of the 3 that just comes to my mind right now. But understanding and developing a process internally to ensure that you are meeting that at 100% of every time. So when we started looking at those data sets, it's all structured data. This is something that's for us, it's Maximo that we use for asset management. Then you have SAP for your CRM, as well as customer billing and all that. Procurement goes through SAP. The quality of the data, just in structured platforms, the DQI was low. So we want, being a technologist, I wanted to have AI applications back in 2018. We came up with use cases where we can automate a lot of processes as well. But the data quality was not there because now garbage in, garbage out. So we had to take a step back. We are actually in the process in 2024 developing guardrails on how to use AI and apply AI 6 years later, 5 years later. So sometimes you do have to take a step back and assess. We completed our structured data analysis. The quality of the data is pretty good. I would say acceptable levels. Now we're looking at unstructured data. These are files in your shared drives, in your emails, pictures coming from the drones. So we have I think 40 drone pilots within the authority and thousands and thousands of images. So now we are actually assessing the health of the asset using the drone images through computer vision. So it takes time to build the infrastructure and the skill sets in-house, and I think you take it step by step.
Yeah, garbage in, garbage out for sure. Peter, you...
One thing I want to add to that, one big area where AI can be applied, as you said, is just in the predictive asset maintenance aspect of it, right? How do you take the network that you have and manage it better and reduce your overall cost of operations? I think when you're thinking about it from a planning process perspective, and you alluded to this earlier, Peter, there is the current way of doing things, which is that you look at your network at a point in time, right? So you're not considering the various different dynamic aspects of what could completely change this picture. And then the tendency is to overbuild, right? But fundamentally, as we're driving the overall grid towards a more carbon-free, affordable, reliable version of what it is today, we can't continue to overbuild, right? Like you cannot, the fundamental challenge is that you have to drive 10x more electrons through the system with maybe 2x more investment at most. Otherwise, there's a big affordability challenge also that you're kind of going to get up against, right? So how do we think about it, from a utility perspective, et cetera, to kind of, part of it is people, process, technology, right? So there is the aspect of trying to make this planning process a little bit better, but how do we move from that mindset that we currently have. I think the tools are there, as you say, right?
Well, and I think you're touching on something. I'll go back to the way you kind of asked the question, because, what's the risk of what's not being done, right? The thing about data, and especially as you begin to get more into predictive analytics, is, one, it exposes the things that have just not been done. Now, we're all humans, and the moment someone shows me that, oh crap, I didn't do my job, or I didn't plan correctly, I'll give a good example is the most expensive unit of energy is the one that you do not have. Over 1 billion don't have it. The second most expensive is the one that's wasted. Line loss is a big issue within utilities, right? But how do we do it? We spend time look at a substation. We kind of go big. We never really get finite. So what we did is we said, well, let's start looking at it from all the way down to the transformer at the house and ask ourselves, now, traditionally, what would happen? The engineering folks would go back and look at their plans and everything, how they built it. They'd say, well, we think likelihood of something here. Sorry, I'm a physicist, so I make fun of engineers all the time, right? But when I could take data and now use data to show me exactly pinpoint where this is the issue, and what we discovered, for example, for us, just reducing line loss by 0.25% could be nearly $1 million that we save. When you can connect it to real money, all of a sudden people are like, oh, wait a minute. So then what we were able to do, for example, we looked at a substation that had about a 4% line loss. We're like, well, we'd like it to go lower, but you know what? 4% isn't too bad. So we can, engineering is not really gonna spend much more time. But when we dug into it, we found that one feeder line had about a 50% loss. So by fixing the one feeder line, it brought the whole line loss of that specific substation pretty high. Well, then the question is, why is that the case? And we went back into the way the distribution design was done was actually not done correctly. So you run into the risk of exposing things that, one, are helping you to figure out how to do this right, but at the same time, from a cultural perspective, it creates this riffraff of, okay, and so, now you get people who are like, I don't know if I want to mess with this data people, because, they're a little weird, and they're going to show things that, rather than saying, well, this could make my job easier, it can go the other way.
Yeah, I think both what Ali said a minute ago and what you're talking about here, I think an interesting component to it that I've heard spoken a bunch of times amongst analytics folks is this idea of like change management and how it's this like massive reorganization of how the organization thinks about and uses data, with accepting that it's going to highlight places that aren't great, but all that data is still good data, is usually what I say. A report that tells you what you didn't want to hear is still good data.
Well, and the other piece of it that's also both really good but also challenging is when you realize the underinvestment on your system. And from a management standpoint, when I got to go to the board and say, we need to spend a lot of money, and you show them exactly where we've not spent, and then they have to think, oh, raising rates, we're electric co-op, so it's not like we just rate base, and, we've got to think it's the impact. And as we say in our industry, the lady at the end of the line who has to debate between medication or electricity, how do we ensure that? So there's that piece of, on a good hand, it's great. Now we really need to make these investments. And now where analytics actually comes in handy is, now how does it help you identify what's the most critical versus, because you're not going to be able to do it all.
Sadia, how about you? What do you see as a risk to these pivotal roles of predictive analytics in the planning process?
I think so. We are approaching it from a part of the utility where innovation and kind of pushing the boundaries is almost necessary, right? Like when you start talking about DERMS and virtual power plants, those applications fundamentally bring together groups within the utility that traditionally don't work together anyway, right? So within that framework, there is probably that psychological safety aspect of it, that, hey, we are fundamentally doing something different, so we are going to learn as we go along. So I think that allows for us to be able to fast prototype and then scale it up, right? I think for us, when we think about it as technology partners to utilities, it is how do we sort of bring all of these assets, all of the distributed energy resources, in the context of being able to actively and proactively manage the distribution network, in the context of being treated as an alternate source of supply, or a supply side resource. It ultimately comes down to how predictable the flexibility is, right? So if the system is saying through the aggregation of all of these DERs, I can give you 100 megawatts, some on the operation side is going to be like, can I count on that, right? Or how reliable are those 100 megawatts? And the reality is that to make those 100 megawatts more reliable, you need more data. You need the machine learning models to kick in. You need to be able to account for everything from assets faulting and the likelihood of that happening, and also customer behavior, right? When you think about demand side flexibility and you're accessing customer sided access, their behavior could be very different in the early part of the DR season compared to the later part of the DR season. So our models need to be able to capture all of these dynamics and continuous. And the thing about AI or machine learning driven, thank you. The thing about AI and machine learning driven models is that it learns with new data, right? So it's fundamentally built for a dynamic world. So I think none of these, when you talk about change management, none of these things are just like, oh, we have the technology solution to solve this problem. There's an organizational structure that helps facilitate that. There is a process aspect of it that helps facilitate that, right? So I think these things need to come together, and with utilities that we've seen that are further down this journey, they have kind of thought of this problem like more holistically, not just as a, hey, let's go and source the best technology out there to be able to solve our problem.
We typically tend to do that too. So as soon as we see a problem, we'll just go out and ask what technology partners can solve this.
Yeah.
But understanding the solution holistically and saying what are we trying to solve, and try to identify those requirements is critical. And that's what we did with NIPA too. So we talked about the asset side. Then as you know, with the new legislation we just received to become a developer for renewables in New York as well, now that's a different side of the business that we have to account for. And it was our ex-CEO that was visionary and wanted us to build grid level models so we can do those analysis as well internally. And that's the Agile lab that was built. So it's real-time simulation models of the electric grid. But now we are getting the data from our assets in as a data point. We have weather forecasting coming in for the next 100-year data points. That this is through a technology partner. We are partnering with the university for load forecasting for the next 100 years. Now, yes, upfront might not be as accurate as possible, but over time, with machine learning, your feedback that you give it, continuous loop, that model is going to get better and better over time. And so internally with the digital twin that we're building now, we will be able to say, okay, what would 2030, 2040, 2050 look like from a generation mix? You talk about DERs, and our customers are not residential. We provide power to municipalities and co-ops. One way that every utility thinks about is just building transmission, adding utility scale renewables is not the solution. Load mitigation on your customer end also helps get you that goal as well. So you talk about supply chain issues. There are so many other challenges that will come down the road as well that we need to tackle.
So I want to shift a little bit. It's similar framing, but I want to dive into more specific examples, specific practical examples. I think so. Let's go through the line again and talk about an example of predictive analytics that you've seen in play or have experience with in play, and what were one or two of the challenges and one or two of the successes around that story. Sadi, do you want to start?
Yeah, I think, again, I'm just going to sort of pick up off of a point from the previous panel where they talked about this in the quest to drive the energy transition, let's make sure that we don't leave customers behind, right? So it's not just the customers who have access to like a storage unit or EVs, which is not affordable to everyone, right? And so I'm going to take the thing that people think is the most unpredictable, which is anything that's behavioral based. Like what you're doing is you're notifying customers and you're saying, please reduce your consumption, right? You would think that this is one of those aspects that I cannot count on these megawatts. Like whatever I get, I'll take it. But we've run these types of programs at a very, very large scale, like nearly 1 million customers at once. And consistently what we've seen is that you get about 0.35 kilowatts per customer. Now at a scale of 1 million, that's 300 megawatts of flexibility, right? And we haven't even started to unleash the machine learning based models just yet. We've just looking at the data in terms of averages, what does that look like, et cetera, you're seeing a fair amount of consistency, right? Now, many factors could be influencing that, because if you take a consumer in the Northeast versus the Southwest, it's, you cannot take these numbers and say this is exactly the way it's going to play out. But again, going back to predictive analytics, you need to create that training data set. So you need to have done this enough number of times where it's like, okay, I can use this data to start to get very, very, start to get more predictable at the individual customer level, right? So when you combine something like behavioral demand response with smart thermostats, with EV VSE programs, with storage programs, now you get the portfolio effect, right? Just like the way you think about an investment portfolio. Diversify it, reduce the risk. It's the same idea, right? And fundamentally, we should be thinking about these strategies as many things coming together rather than an all or nothing, right? Like invariably, some of the conversations are like, why do I bother with the demand side flexibility if I can just go ahead and deploy utility scale batteries? Yeah, in some cases, that may be the right answer, but that's not the only answer. And we should never think about, especially with the world that we're facing and what we're looking at in terms of the increase in demand and the carbon-free challenge that we're working towards.
Sorry.
Thank you. You cannot say, I'm not going to use some tools in my toolkit, right? You have to have access to all of them. You have to have the ability to use all of them. And then you decide for any given situation what combination of tools or strategies or solutions makes the most sense. So I took the behavioral example because it is at that one end of the extreme in terms of something that you would consider as a non-predictable resource. But of course, the right way to do this is to think about it as like a portfolio where you can then reduce the risk and combine fast responding assets and slow responding assets to still get you that very predictable dispatch grade megawatts.
What was one of the challenges to building that model? Because it sounds like you had a lot of very granular data, and I can imagine a ton of challenges. But what were some of the challenges that you experienced?
I mean, it's the data quality challenge or the data availability challenge in some cases, right? Because our ability to be able to do or figure this out at a granular customer level means fundamentally AMI infrastructure, which is not a consistent thing that's available across all utilities, right? And if we don't have that infrastructure, then where are we getting similar data from? So I wouldn't say data quality as much as just like purely first principles data availability. Like, do we have the data to be able to make these kinds of predictions?
Yeah, it's as data rich as the world is, it's weird that you still run into lots and lots of places where you're like, wait, I don't have data for this? How about you, Peter? What's an example of predictive analytics in play that you've seen?
Sure, I was going to use the example of how often will her chair move over this way, as a successful example. But sorry, ADD, I get distracted quickly. All right, quick question. Who knows the most popular product at a Walmart?
At a Walmart?
Yeah.
Is it diapers?
No. It's the thing that you would never think about. It's bananas. And I was at an analytics conference when this was brought up, and it was all about predictive analytics and how they figured out a way in people's behavior that they could actually sell more bananas, and then they place the bananas close to something else that they want to sell. So I did the test myself, and I had not been to a Walmart in years, and I really went straight to the TV section because there's no way you're going to have bananas around there. But guess what? Literally just close enough, those set of bananas. So from a utility standpoint, now that I've given you all a fact that, to me still shocks me up until today, I would say one of the biggest things, and I'm going to piggyback on where you're coming from an example. We, like any utility, we run demand response programs. Telling people what to do is not easy. I can tell you that much. I'm in Virginia now. When I lived here in Texas, for example, you have 2 seasons, hot and hell. And during the hell months, I'm sorry, no one's gonna, they want their AC, right? And, so what we began to look at was we're putting so much work into this demand response program that how much more you're going to get, how much juice can you squeeze out of it anymore? So we actually began to look at data, and we, data scientists, they began to really look at closely and write models to say, what can we predict based on other consumers? And what was interesting is we identified 5 CNI that if we just put a battery on their site and we ran the economics of it, and this weren't big scale, none of them were even a megawatt or higher, but because of the way they used electricity at the time, we could reduce essentially almost half of what we do with our residential consumers. And, it was like, okay, so we've been working so hard, and then in like a day, this guy comes up with the most brilliant thing. It's like, please, I hope I keep my job, because, but you can see how that, for example, can now, now, the tougher part is there's a lot more you've got to do with the data. Part of what we realize is, was the data in the shape that you wanted it? No. I look at our metering system, we're getting ready to roll out our AMI 2.0, but we're at places where we don't have, we ping the meter, every 8 hours. So we, that data looks very different than the one that I'm doing 15-minute interval, right? And so there's that piece of it that we've discovered that as a challenge is really how the data is in shape and how it's curated, and figuring that out actually is a fundamental piece to seeing some success in this. So that's just an example of how it can really be successful in identifying things. But then the challenge is now the tougher part for us is how do we now collectively say it's not an this or the other? How do we go with all of the options, because all of them can, and which one competes for the resources? Because we know, to your point, I can reduce load and I can do something else here, and it can all come together collectively. And so that's we haven't written the model of trying to figure that out yet.
I just want to add on a couple of things that Sadia and Peter covered. One, and I'm going to give a different example. I've been talking about utility, assets a lot, and we did use GE Predicts as our software for advanced pattern recognition. We get thousands of signals every day, but Smart Signal is a tool that GE Predicts provides that eliminates all the white noise. So that definitely helped us in the long run to focus on the critical alarms. On the customer side, we have a fierce leader in the back that was leading the New York Energy Manager. One thing you mentioned was data availability. I think the other aspect of it is the willingness to share data so you have the right data. And I think that's what one of the challenges that we seen at NIAM was, that was actually formed to address Executive Order 88 and 166, is to reduce the energy consumption by 50% in state buildings over 25,000 square feet, and also carbon footprint. But collecting data is a challenge. Them coming online on our platform was a challenge, right? It's the willingness to share data as well. I think that's a big component. When you we don't directly deal with residential, but that data is very important. And if you don't have all the pieces put together, it's hard for you to successfully predict anything for the future. I mean, you will have a result, definitely not a more appropriate result that you will be considering, right? So.
Yeah, no, I mean, as much as this is a talk about predictive analytics, you really can't have predictive analytics without data, right? And you have to have good data, and it has to be thorough and in the right shape. Absolutely. From here, I think what I want to do is shift over to forward-looking stuff, and I'm going to shift to one of my bonus questions. So, like, an innovation within predictive analytics, specifically with regards to long-term planning processes. What are some innovations that you guys see on the horizon that you're excited about for this part of the world? Go back to you, Ali.
I don't want to sound like this is a sales pitch, but we are investing over $40 million in building what we call Agile. Phase 1 was completed with the real-time simulation model. Leveraging that as a foundation, now we are building the digital twin at the grid level. The word digital twin is used very loosely in the industry. You have digital twin of the assets. A lot of vendors provide that. There's a lot of technology partners and utilities doing that. But we'll probably be the first in the world to actually build the digital twin at the grid level using, I would say, near real-time data from our assets. We have PMUs across the state that we have installed, phasor measurement units. Those are the most accurate data that you can find on the grid. That is definitely one of the most innovative projects that we are currently. We actually have a booth out here if you want to see stop by. We have a couple of engineers that are working on this technology, but that will help us not only support NIPA's goals and also the state with reaching their 2030, 2040, 2050 net zero goals, right? So that's definitely one of the biggest innovation projects we're working on.
So you said something, you can't have analytics if you don't have data. You also can't have analytics if you don't have power, right? And the irony of sitting here talking about analytics, if you followed what's been happening on data centers, Virginia is one of those places that today, 80% of data does travel through Northern Virginia. So we are at, I would say, probably the fastest growing utility when we look at data centers in the nation. Just the public ones, and Cheryl's here handling some of what we need from a power supply perspective and the market and everything. But if you look at PJM's market report and everything else, they actually list 4 utilities, and that's Dominion and 3 co-ops in Virginia that are going to really require a lot of data. And to put it in context and how we had to explain to our folks, the public data centers right now that's been announced that I could talk about take us from 1.2 gigawatt loads to 2.4 gigawatt. Yeah, and that's not in a long time. That's quickly in the next few years So, and I'm going to get to why I see some innovation in where we need to go, right? And so I'm looking at that from understanding what I'm going to have to deal with in terms of providing power to those data centers, but also to the 180,000 plus consumers that we serve and continuing to grow as well, that I need to now figure out how to balance this thing. And I can't balance it the way I always thought about it, right? It has to look a little bit different because I know the demand for energy is going to continue to grow. So one of the innovative things that we're looking at is really how do we do the dynamic forecasting and really down to the real time, because I can't give our control center people are not comfortable not knowing that they're going to have those resources, right? But if I could give them something that's really dynamic, that is really, I'm saying real time, although it's more like near real time, but I want real time, right? Because then I can also tie it into what's happening on the market, and how that plays out. That to me is going to be one of the most fundamental innovations I think we can address, that actually will be something that we need due to the variability of energy as we look at our system. So I think as we look into the future, how we power these data centers and continue to power everyone else, navigating that and using analytics to really, my goal is I want to be, the previous session talked about coming in, the lady from Smart, wanting to, Nike shoes and getting an ad. She's like, how did they know when I walked in? I would like to be the one who says, and you shall use this much power now, and you shall use this much, because that's really, it sounds a little crazy, but in our lives, that's what's happened to us. I just buy things because Amazon tells me to buy them, and I don't realize I'm like literally a puppet, right? That's what I am. But what if we thought about it that way from an energy standpoint? And how do I use analytics to really drive that piece of it?
So I'm going to, a lot of what you talked about is the sort of where do we want to go and the North Star in terms of the direction in which that we're headed, right? So I'm going to focus a little bit more on the next set of things that we could do that are still innovative. When you're thinking about the long-term planning process and all these loads that want to come online, one of the things that I've seen from an innovation perspective is business model innovation, right? How do you engage with these new loads that want to come online in a flexible way, where you say, look, most of the time I can give you this much, but during those periods of constraint, I may need to curtail you. And me as a consumer, if I'm trying to get 6 megawatts online because I want an EV depot, I'm like, yeah, I'll take it. I don't want to wait another 5-6 years until your network is ready to be able to take this load on. So I think that, being able to put in place those kinds of structures that still keep those customers connected, and in turn, those customers can then offer those flexibility services as well, or be part of that sort of aggregated flexibility resource. And then more on the generation planning side, I think, at least in terms of when utilities are doing their integrated resource planning, you can start to see demand side flexibility or storage driven flexibility show up as real separate categories. Now, we do recognize that we have some ways to go to get there, but the fact that it is even in there, I think, is a pretty big step forward in terms of realizing that from an innovation perspective.
Yeah, although it's interesting, as much as we were talking a lot about data, none of the innovations are data focused. Still using data, but not fixing or working on the data problem.
Well, that goes back to what is the value that your data is creating, right? Which is the right question to ask.
Which is one of the things we talked about as part of the prep is finding to do predictive analytics, right? You have to find that good question to frame, to use the data to do your predictions on. And it's really hard to get at what is the good question to ask. But I think a lot of the innovations that you guys are talking about are definitely going to help us at least open up the field of what questions we can ask, which is an important piece of that puzzle.
So, one of the things we've been working with our employees is changing that mindset of thinking, what's the right question? And I just talked about, the load that we're seeing in data centers, 500 megawatt data center, 500 megawatts. Our employees just could not put that in context. We had to say, okay, when the largest load we've ever had was about 40 megawatts. So they're like 500 megawatts, they just could not put it in context. So for them to ask any questions, it's not, they just don't have the context. But when we said, oh, okay, think of it as, okay, that one large load, okay, maybe about, 12 or 13 of those, yeah, it still wasn't hitting home. But when we said, okay, well, most super Walmarts that we have a little bit of a megawatt load. So think of that as 500 super Walmarts. And all of a sudden they go like, all right, so what do we need to know, and what do we need to think, And that just shows you the example of why we have to shift in how we ask the questions on the analytics side, because if your mind frame is, if you're still framing everything in the context that you just see it as it's this big, massive thing, you may not be able to get there. But if you slice it into that many small pieces, all of a sudden it's saying 500 super Walmarts, everyone is like, oh, well, what do we ask? But then it became a point of, we can actually do this. It wasn't as challenging anymore. And so it's the same thing that we're trying to do with data is, how do we change that mindset?
Yeah, and I think that's another nod to change management, right? Of people who are not data analysts are the ones that are going to end up, kind of at the edge of the product set that we're talking about. And so we need to help them understand the value that's in those products and just how to start thinking about things in different ways, for sure. Speaking of asking questions, does anybody have any questions? Do you want to come up to the mic and ask? You get it.
Flip it up.
Flip it up.
There you go.
Will you see the mic
There. Hello. There you go. So hello, my name is Hilario Urquieta from CPS Energy in San Antonio, Texas. First of all, I want to thank you. This has been a great topic. I'm topic of great interest to me, right? The predictive analytics side, right? So my question to you all is, in our energy industry, which is characterized by often unpredictability due to weather, regulation changes, evolving customer demands, right? What areas do you recommend be the starting point or the key areas to invest in predictive analytics? And I'm interested to what was the driver for this agile implementation, which is, I heard about it yesterday or today, I think, I can't remember. But I want to see what was that driver and what were you aiming to solve, right?
I can start and talk about the drivers, right? So one of the things that we realized early on, 2016, 2017, is decentralization is going to be a key part for the utility of the future. And it's not a one-way street anymore. It's going to be eventually two ways. So if we can build a model that can help predict and assess, right? So for example, the model will know from generation, transmission, and we don't have distribution, so it's aggregated load for distribution on in our models. But what if you have 2,000 fast chargers that are being installed on a feeder, like in one area? How does that impact transmission and generation? Vice versa, looking at your assets, and unfortunately, one of the transformers not working, and it's a 2-year lead time on getting a replacement. How does that impact the flow the other way? Now, with the other component was solar rooftops, community solar. Community solar is one of the biggest, successful programs in New York. How does that impact the load requirements? There's a lot of questions that we had that we said, okay, at that point, no technology partner was available to answer all of those questions at once. So we partnered with a number and came up with a program that helped us define what those requirements will be for our future. And that's how we designed the roadmap for this Agile Lab.
Yeah, I'll be real quick, and I think it's kind of very regionally, right? So, for example, I used to work next to you at Pedernales Electric. I know the Texas issues, right? So if I was thinking Texas, I'm thinking those reserves that are coming up, in the summertime, and the governor pleading with people to reduce their usage and everything. So I would probably invest in how do I address that, right? But when I look at where we are, for example, one, aging infrastructure is a big issue. Two, we recognize really quick that we're central to a transportation network where our territory covers 4 major highways: I-64, I-95, I-81, and I-66. So we know from an electric transportation standpoint, we were going to have a lot of issues. And to his point, we decided we need to invest in that area in analytics because we need to really begin to understand what we need to do to not have to keep replacing those transformers because it was already happening. We're already seeing that begin to impact us a little bit more. And so, now the sad part is in doing all of this, then you realize, oh crap, I had 40% of electric vehicles in my system, about 55% of my transformers at nameplate capacity. Not a good place to be. And if you don't understand what that is, that's like driving on E and seeing how many miles you could go, right? And now I'm guilty of doing that so many times. So the investment to me is not only originally, but you have to understand where does it really look at your system and seeing where would be. And for us, that's how we approached it in looking at our investments.
I mean, our role as a technology and services partner to utilities, and CPS, as you know, is a great example of this in terms of how they're driving the Flex Step program to decarbonize and change their generation mix to include flexible resources, right? So our existence is based on the first principle assumption that distributed energy resources and customers are going to be at the center of the energy transition. And I've been working with Uplight and the company that Uplight acquired, which was Autograde, for 6 years now. And I remember earlier in my career, it was like, yep, it's coming. And then at some point, you could see the conversations change. And it's like, it's here. This is a here and now problem. How do we solve it, right? So those dynamics have borne out. Even though this the hypothesis upon which the company and the technology was built is about now 10, 12 years ago, I think we're starting to see a lot of that sort of urgent need for these types of solutions much more now than even, I would say, 4 years ago, right? So I think it's been proven true in a lot of ways.
Appreciate you guys for the interesting panel, but I just had a question for Peter. Those 5 CNI loads you were talking about, what type of load and what was their load profile? You said they were able to run at a time that was beneficial to you guys?
Trying to remember what type of loads they were. You know what? I'll give you my card and I'll follow up with that. But because I don't want to lie to you, I could come up with a really good answer, but probably. But yeah, but no. Where we had to identify. So first of all, we kind of did just look at the load without even looking at what the entity actually does. And so it's kind of like you anonymize how you approach it, because immediately, for example, there was one place that we were like, yeah, I'm not sure they're gonna want to, reduce their load because of the kind of entity they are. And the reason why I wouldn't tell you what it is because we serve a lot of 3-letter facilities in the Washington D.C. area. So, but so there's that piece of it. So if you can blindly go into it without understanding the actual entity, and then look at the load, and then after that identify what can you do with that load.
Any other questions? So I think maybe if you guys want to give a parting thought about how, how and why, or pick one of them, predictive analytics is something that definitely is not going away.
I just want to be able to do the whole Walmart thing and get people to buy bananas, right? And so, but I say that as a joke, but the truth is I don't think it goes away. I think it becomes, there's a certain point where it was looked as the enemy. I think we're getting past that. Where I see it is how do we make it the friend? And the thing that every day in your job, it's the thing that you're using. And that's why I believe, and I'm very optimistic that it's here to stay.
It's making all of my high school math teachers happy. You're going to use algebra later on.
One thing I'll add on to it is it's definitely a friend, right? It's a tool that helps you understand the problem, getting the insights, understanding what insights is there. At one point we were having a conversation about, is AI going to replace jobs? It's not, to the extent. It will help you, give you enough insights that you can make a decision. It's not about control. Like, AI is not going to get command and control. It's still the operators that will still have to control the assets in the substation, but it's the data scientists that are going to extract the data, understand where it's coming from, and then provide the recommendations up to the control room, right? So that's something that to keep in mind. So it's not going away. It's a tool that will help us achieve these goals in the future for sure.
I will never write another job description, just so y'all know.
I mean, fundamentally, I believe organizations are incentivized to figure out how to do things more efficiently and better, right? And this is it's going to be that sort of bedrock in terms of the tools that organizations have at their disposal to be able to do things more efficiently and prepare themselves for this dynamic world that we see ourselves entering into, increasingly dynamic world. So if you think of data as gold, the tools, the data analytics, the predictive analytics tools are the picks and shovels to be able to, figure out and make sense of what data is out there and how you use it. I mean, at some point it's going to be a innovate or perish, right? We're going to be faced with that decision making. But I also don't think it'll get to that. I think fundamentally, organizations are going to want to do things more efficiently.
Thank you, everyone. Really appreciate it. I guess we're going to end a little early. It's like 5 minutes early, I think. But oh, we're late? Oh, sorry. The other side. Sorry. Thank you very much.